Hey guys, welcome to question MM241 of the Maths Methods Fortify study guide. So, we've got a walking track that winds through a park in Melbourne, which is modelled by the function h of x equals 5 on 2, take 2 sine of pi x on 3, where x is between 0 and 9 on 2. From points A to B. So A is the walking track up here to point B. Now, all values are given in kilometres, so that's something important to remember. So we're in kilometres, and a bird's eye view of the track is shown here. So part A, or part AI, which is just 1 mark, tells us a river runs along the x-axis. So there's a river along here. There's a kayak station at origin O where kayakers can hire kayaks and paddle down the river in the positive direction of the x-axis. So kayak station here, they can paddle down the river this way. How close can walkers on the path get to the river without leaving the path? Give your answer to the nearest meter. Awesome. So first things first is to recognize where the path is closest to the river, right? And if this x-axis is the river, then our closest point to the path is going to be, or to the river on the path is going to be here, right? Because they're not allowed to leave the path. So without leaving the path, this distance here is going to be our shortest distance. So because this is a trigonometric function, we can see that this is the minimum value of that function, which means that the minimum is going to be equal to the midpoint of our trig function, which is 5 on 2, minus our amplitude, which is 2. So 5 on 2 minus 2, which gives us 1/2. But we're asked to give our answer correct to the nearest meter. All values are in kilometers, so this is 1/2 of a kilometer, which is 500 meters. So 500 meters is our closest distance, our first and only mark for this first question. And then, yeah, that's it. So let's move on to part AII. So part AII is, again, just a 1 mark question. Do we have our CAS? Yes, so we do have our CAS for this question. AII, 1 mark. Sweet. So the question asks us, what is the average rate of change of h between points A and B? So whenever we have the average rate of change, we always need to think gradient. So we're thinking gradient between 2 points. So the gradient from here to here, okay? Which means we're going to need to find coordinates, right? Sorry, had a bit of a mental blank just then. So A occurs at x equals 0, right? We know that the track starts at x equals 0, and we can find our y value based on that, right? So h of 0 is equal to 5 on 2 minus 2 sine of pi times 0 over 3, which is just 0. Sine of 0 is 0, which means h of 0 is equal to 5 on 2. So A occurs at 0, 5 on 2, and we then need to find our B value, which our x value at B is 9 on 2, right? Because it finishes at 9 on 2. So h of 9 on 2 is equal to 5 over 2, take 2 sine of pi on 3 times 9 on 2. 5 over 2, take 2 sine of, now pi on 3 times 9 on 2 is 9 pi over 6, which is 3 pi over 2. Sine of 3 pi over 2 is -1, which means we get 5 over 2 plus 2, which is equal to 9 on 2. So our B value occurs at 9 on 2, 9 on 2. Awesome. Now you can just do all this in your calculator, but I just wanted to show you how to do that. So now that we've got our A value and our B value, it's going to rewrite A down here, 0, 5 on 2. We can plug it into our gradient formula, right? So because we're looking for average rate of change, what we're looking for is y2 minus y1 over x2 minus x1. So first y value, 9 on 2, minus second value, 5 on 2, 9 on 2 minus 0. Awesome. Now 9 on 2 minus 5 on 2 is 4 on 2, which is just 2. So 2 over 9 on 2, which is equal to 4 over 9. So the rate of change from A to B is equal to 4 over This is our first and only mark for this question. A little bit of working for 1 mark, but you're just going to get those questions every now and then where you have to do a bit of extra working. So that's part A, I. Let's move on to part B. Part B is a 2-mark question. And it says, the council of this area is thinking of building another kayak station at point P so that kayakers can travel along the river from O to P, exit the river and walk up a dirt track from P to Q. Q is a point on the graph of h of x. Kayakers typically travel at 5 kilometers an hour along the river and 8 kilometers an hour on the dirt track PQ. Awesome. So kayakers are jumping in here, traveling along the river at 5 kilometers an hour. Then they're walking up this dirt track here, PQ, which is 8 kilometers an hour. They're traveling. Awesome. Part B. If the dirt track PQ is perpendicular to the river, show that the total time taken for a typical kayaker to travel along this route OPQ is given by the equation t equals 1 over 80 outside of 16x minus 20 sine pi x on 3 plus 25. Sweet. So, let's think about what time is, right? So, we know that distance is equal to, speed is equal to distance over time, right? Which means that our time is equal to distance over speed. So whenever we've got a question that talks about finding the total time taken, we always have to kind of use this formula. So we're going to break this up into 2 parts. We're going to break it up into our time that it takes for us to travel down OP, and then our time that it takes for us to travel along PQ. So our total time is going to be equal to our first distance of OP over our speed along OP plus our distance along PQ over our speed along PQ, right? Because we've got this time and then this time, and those two added together are going to equal our total time. So our distance from O to P is simply our x value, right? If x is equal to 2, then that means that we get 2 kilometers along, which gives us 2, right? So our distance is simply just x, because it's just our x value. Our speed along the river is 5 kilometers an hour. So our speed is 5, right? So that's the time it's going to take us to travel from O to P. Now from P to Q, our distance, because this track is perpendicular to our river, our P to Q value is simply the y value of our h of x, right? So at Q, this is equal to our y value at this point, which means that we can simply use this formula to find our y value, or our distance, right? So our distance is actually going to be 5 over 2 minus 2 sine of pi x on 3. And our speed is 8 kilometers an hour along that dirt track. So over 8. Now we can start to basically rearrange this. So this is our first mark here. Now we basically want to get this in a form that looks like this, yeah? So what we're going to do is we're going to say that t is equal to x on 5, and I'm going to take out 1 on 8 as a, actually, you know what, let's just put it in now. So 5 on 2 divided by 8 is 5 on 16, minus 2 divided by 8 is 1/4, and then we've got our sine pi x on 3. Awesome. Now we can keep rearranging this. And what we actually want to do is create a common denominator of 80, right? Because the question, like the formula that we had at the start was t equals 1 on 80 outside of something. So for us to create a denominator of 80 here, we need to multiply 5 by 16. And if we multiply 5 by 16, we've also got to multiply the x by 16. So we get 16x over 80, plus to get to 80 from 16, we need to multiply that by 5, which means we need to multiply the 5 by 5 as well. So we get 25 on 80, minus, if we want to get this to be 80, we need to multiply that by 20, which means we get 20 over 80 sine pi x on 3. Taking 1 on 80 out as a common factor, we get t equals 1 on 80 outside of 16x. And just to conform with what the question is asking us for, I'm going to take this term first, which means we take 20 sine of pi x on 3 plus 25. This is our second and final mark for this question, and that's it. So let's move on to part C. Part C is a 3-mark question, and we're going to start using our differentiation skills at this point. So, part C, 3 marks. The council wants to build kayak station P such that kayakers can travel from O to P to Q in the minimum possible time. Find the coordinates of Q in this case, giving your answers correct to 3 decimal places. Awesome. So we're trying to find this point here, which allows the kayakers to get to point Q in the least possible time. So we know that the time that it takes them to get to point Q is 1 over 80 times 16x minus 20 sine of pi x on 3 plus 25. If they get there in the minimum possible time, that means that the derivative of this time function is going to be equal to 0, right? We should be pretty comfortable with that by now. So dt dx is equal to 0. According to our CAS, which we have available in this question, 0 is equal to our derivative, and our derivative is equal to 1 on 5 minus pi on 12 cos of pi x on 3. Awesome. And then we can simply sub from here. So this is actually our first mark here, just identifying what the derivative is. And now we can actually just rearrange and solve for x. So we get 1 on 5 equals pi on 12 cos pi x on 3. Dividing both sides by pi on 12, we get 12 over 5 pi equals cos of pi x on 3. So the inverse cos of 12 over 5 pi is equal to pi x on 3. Therefore, x is equal to 0.670. This is our second mark. So this is the x value of this point here, where we need to travel 0.670 kilometers this way, and then go up to Q, and that'll get us there in the minimum possible time. But we haven't finished yet, because we're looking for the coordinates of Q. So Q lies on h of x, which means that in order to find our y value, we simply sub in 0.670 into our h value, or h function, and we get 5 on 2 minus 2 sine of pi times 0.670 over 3, which is equal to 1.209. Which means that our Q occurs at 0.670, 1.209. This is our third and final mark for part C. We really need to make sure that we state the coordinates of Q, because that's exactly what the question is asking for. It wants it correct to 3 decimal places, which we've done. So that's it. Let's move on to part D. Part DI tells us that the council decides to build an abstract sculpture at point Q. The sculpture consists of a metal frame in the shape of a square-based pyramid, which contains a solid metal square-based rectangular prism. The side-on view of this sculpture is shown below. So we've got this diagram here. So basically it's a pyramid frame. So like there's nothing inside the pyramid, it's just like a frame of the pyramid. And then there's a rectangular prism inside that's solid. So the base of the pyramid is 6 meters long, and it has a height of 5 meters. So the total height of the pyramid is 5. The base of the rectangular prism has a width of W meters, and its height is H meters. Show that H is equal to 30 minus 5W over 6. Awesome. So first things first is to recognize our similar triangles, right? So whenever we've got a diagram that looks something like this, we're going to need to use similar triangles. So what we're going to do is actually create a triangle system. So we're going to take this large triangle here on this side, and we're going to make it its own triangle. So this triangle has a height of 5 meters and a base of 3 meters, right? It's half of this total thing, half of 6, so we have a base of 3 meters. What we also have is this little triangle in here. This triangle is inscribed within this larger triangle, which means they must be similar, which means that their side lengths have the same ratio, right? So we've got our other triangle, our little one, which has a height of h and a base, which is this section here. So if this half is 3 meters, so this bit here is 3, this whole bit here is W, that means that this is W on 2, which means that this section here is 3 minus W on 2. So this is 3 minus W over 2. Now, we have to relate these two lengths together. If they have the same ratio, then that means that this over this is equal to this over this, right? So 5 over 3, so therefore, and this is only a 1 mark question, so this is a fair bit of working, but you're just going to get those sometimes. So 5 over 3 is equal to h over 3 minus w over 2, right? Then from there, we can actually just rearrange and solve for h, because we want to get h by itself. So we multiply both sides by 3, take w on 2, so we get 5 times 3, take w on 2, and we multiply both sides by 3 as well, which means we get equals to 3h. So here we get 15 minus 5w over 2 is equal to 3h, and then rearranging this, we end up getting h is equal to 30 minus 5w over 6. First and only mark in this question, guys. That's our final answer for part DI. Let's move on to part DII. Part DII, again, is simply a 1 mark question, and we're asked to find the volume of the rectangular prism in terms of W. So we know that the rectangular prism is this section here. We know that it's a square-based rectangular prism. The question tells us that, which means that this side and the other side, as in like the side, this side is also W, right? So our volume is equal to length times width times height, which is equal to W times the height, which is h, right? We're trying to find the volume in terms of W. We know that h is equal to this, which means we can say the volume is W times 30 minus 5W over 6. What we end up with is simply W squared outside of 30 take 5W over 6. That's it. So that's a 1 mark question. Again, pretty straightforward. Just keep in mind that it is a square-based rectangular pyramid, so we can make that connection there. Awesome. Let's move on to part E. Part E is a 2 mark question. And it says the council designs this sculpture such that the volume of this rectangular prism is at a maximum. So again, guys, as soon as you see the word maximum, we know we're going to need to find the derivative of the volume or area or whatever and make it equal 0. So in the previous question, we found that V was equal to W squared times 30 take 5W over 6, which means that we know that dV dW is going to have to equal to 0 at the maximum, right? So dV dW is equal to negative 5W outside of W take 4. Doesn't matter what format you put this in, you'll get the same answer eventually, which means that that is equal to 0. Now that's our first mark, and our second mark is going to come from actually finding the value of W that it is at maximum for. So 0 equals negative 5W, W take 4 over 2. Multiplying both sides by 2, we get 0 equals negative 5W outside of W take 4, which means that W equals 0 and W equals 4. Since W has to be greater than 0, right, because the rectangular prism wouldn't exist if W is equal to 0, W equals 4 meters. And that's our second and final mark for part E. Let's move on to part F, where we're asked to state the rectangular prism's maximum volume. So again, another 1 mark question. But now that we know our W, I shouldn't have rubbed that out. We know that V is equal to W squared 30 take 5W over 6. We know that W is equal to 4 meters when the prism has a maximum volume, which means to find the actual volume, we can sub in 4 for W. So 4 squared outside of 30 take 5 times 4 over 6, which is equal to 16 times 30 minus 20, which is 10, over 6, which gives us 80 over 3 meters cubed. Again, we didn't get asked to find its correct decimal places, so we need exact value. And we also need to make sure that we include those units there, because that's going to be really important. So that's our first and final mark for part F, and that actually marks the end of MM241. So guys, thanks for watching. Let me know if you have any questions in the comments below. But otherwise, thanks so much for watching.